All right, so for warm-up 82, you are going to need a die. So dies are back here. And on your Chromebook, look for the free app to make a spinner. And do that on paper, please. Once again, you need a die, and you need to create a spinner. I'll give you guys some time for that. And it says do that 6 times. So you roll the die 6 times, spin 6 times, and see what you come up with. Go. All right, show your neighbor what you did really quick. See if they have something similar to you. You can get this show on the road. All right, so it says, warm-up 82, get a die and a spinner, then toss the die and spin the spinner. Do that 6 times. Make a table to record your frequency, and then find the probabilities of all your frequencies. And then from there, what kind of probability is there? All right, so let's see. Start us off. Well, haven't we called on in a while? How about Cole? Cole. So what kind of table did you make? All right, so it's a 2-way table. He said this one. So you did 1, 2, 3, 4, 5, and 6. Did I see it right? And then over here you did what? Was it colors or letters? All right. Red, blue, and green. So 3 of them? Okay. So then you spun and you tossed 6 times. So give me your frequency. 1 red, 1 green, 2 blue, 3 blue, 4 blue. Hold on. 2 blue once. Okay, and then 3 green. All right, so let's find the probability of 1 red. Probability of 1 red. So what was N, everyone, according to the instructions? N was 6. So therefore, Cole, to roll a 1 and a red would be 1 out of 6. That is correct. And that's how you find the probabilities for each of those. And looks like most of them are going to be 1 out of 6. Unless you have like 2 tallies or 3 tallies in one spot, then it's going to change. Yeah? Well, that's for Cole. I don't know how you guys did your spinner, but something like that. All right. What kind of probability is this? Tell your neighbor, please, and then Cole's going to pass someone. What kind of probability is this? All right. Good conversations. Pass someone. Sam. It's either classical, empirical, or subjective. That is correct. Empirical. Tell your neighbor why it's empirical, everyone. All right. Pass someone. Sam. Why is it empirical, Amelia? No, this activity. Why was it empirical? Yeah, because you have to go through the experience to get all frequencies. Yes. All right, send that in, please. Copy the agenda. Warm-up number 82 is done. Today we're moving on to multiplication rules of probability. 2 days ago we did addition rules. And tonight's home plate page is 222, 223. Michael Jordan. 2 to 10 events only. Events only. Copy that. All right, copy the code for your home play access, CYHSV. 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 So remind your neighbor what yesterday's home play was. Very good. Study your formulas. All right. And tonight's home play is there. Get a Cornell note ready, please. And here we go. I can identify and compute the basic probability. I can identify and compute the basic probability. Like I mentioned before, we're still in the middle of the introductory phase. We're moving on slowly but surely. And we already got into the portion where we start with the rules. Last session, 2 sessions ago, we did addition rules. And just to make sure we know what probably we're talking about classical, empirical, and subjective so far, yes? We talked about exclusive events versus non-exclusive or non-mutually exclusive. And that's when we did the addition rules. Well, today, instead of talking about mutually exclusive and non-mutually exclusive, we're going to talk about events that are independent and dependent. Write that down, please. Events that are dependent and independent. Now, I'm pretty sure you've seen movies where the outcome of the movie has to do with a lot of little things that happen in between in the movie. And people are like, oh, the reason this happened is because this had to happen before this happens, and so on and so forth. Well, today we're going to be talking about those events, but now using the artifacts that we've been using so far, like die, spinners, and such like that. But let me introduce this, let's see, dependent events. Before you write the definition, really quick story, being that we are in actually this week, long time ago when I was in high school. I remember it was getting closer to Valentine's, and I think I already told you the story, right? That I made up my mind that I was going to ask my friend back then to see if she wanted to go out with me. Woo! Let's go! So, I sat across her in the class one day, and I did a sketch of her, and then from there I framed that sketch. I wrote a little poem in the back. Oh yeah, I was hitting all the check marks right there. And I said, and then I'm going to give her a little stuffed animal. I'm like, oh snap. I wanted to be original, so I gave her a gorilla. Right. So I put it all in a little baggie, so here I go. And then I said, okay, do I wait till after school so that she's by herself? And I said, nah, I'm going to step up right now. And I went out, and I saw her. She was over there with her friends, and I was like, oh, snap. All right, here we go. So I approached her, and then all of a sudden I'm like, I called her name, and then she turned, and all her friends turned at the same time as well. They're like, and I'm like, okay, all eyes on me then. And I said, here's a gift, and don't open it till you get home. She's like, oh, okay. So then I gave it to her, and then I left, and then I was walking on the way, and now I turned to see what was going on, and of course everybody was like talking about it. I'm like, what? So anyways, I got home, check this out, and then after school I got home, right away I went to the phone. I kind of like figured out that she was already home because she got a ride home from her dad, and then, hello? Hey. And then she's all, oh, hi. And I'm like, so, she's all, thank you very much for my gifts. And I said, well, I wanted to see if I can come over and I needed to talk to you. And she's all, wait, before you say anything, I don't want to date you. Woo! From the corner. I was like, what? I didn't say what. I was like, in my mind, I was like, wait a minute. Did I hear it correctly? Anyways, so, long story short, fast forward. Right now, I wouldn't be married to my wife if she wouldn't have said no to me. Then I wouldn't have been persistent after that one more time in order for us to start dating and then get married. That is a dependent event over an event. So one needed to happen for the other one to happen now. So, I just wanted to share that because it was around this time, guys. It was getting closer to Valentine's when she saw, I don't want to date you. I was like, what? Anyways, write this down. Independent events. They are events that occur without affecting the probability of one another. And obviously, with the story that I gave you, dependent events affect the probability of one another. Man, imagine if that happened to you guys. Woo! Man, that's a tough one, right? Everybody got quiet. Their mind is going 100 miles an hour. Those of you that are on YouTube and following along, they're like, even though they're writing math stuff in their mind, they're like going 100 miles an hour. But anyways, we had a happily ever after. Aww. So, and of course, today we're going to start with events that are independent. Independent meaning that the probability of one happening to the other does not affect either one. Whereas dependent, it does affect either one. Down, new rule, multiplication rule. Once again, you don't have to copy all the verbatim exactly how it is. Just copy the rule itself. That's what we're going to use. P of A and B is equal to P of A times P of B. So that is the one that we use whenever two events are independent of one another and do not affect the outcome of one another or the probability of one another. P of A and B is the same as P of A times P of B. And if you notice from 2 days ago, in regards to the addition rule read P of A or B. You guys remember that? And that's how we distinguish it from the multiplication rule. All right? So, copy this problem down, please. Example 1Q, write it on your paper, please. A coin is flipped and a die is rolled. Find the probability of getting a head on the coin and a 4 on a die. Write that down, please. I'll give you time. Go. Go. So, for this one, let's start with the formula. Write out the formula, please. Let me zoom out. We start off with P of A and B is equal to P of A times P of B. So, what are they talking about? Find the probability of getting a what? A heads on the coin and a 4 on the die. So we write P of H and 4, which is P of H times P of 4. So, I want you to think about it, and remember, these are events that are independent from one another, and the probability does not, for each of those, does not affect one another. So therefore, Turn to your neighbor, let them know what is the probability of flipping a heads. Probability of flipping the heads. All right, looks like Santi's got this one. Santi, go. 1/2. That is correct. Therefore, tell your neighbor the probability of rolling a 4. Probability for rolling a 4. All right. Aaron, what you get? 1/6. That is correct. Therefore, the probability of rolling a heads and a 4 multiplication is 1/12. All right, from 1 to 5, I'll come through. Are you with that so far? Yeah. Okay. Example 1 Super Q, and it reads, a card is drawn from a deck and replaced. Then a second card is drawn. Find the probability of getting a queen and then an ace. So copy the entire problem, please. Only the verbatim. You don't need to copy the picture down here, just the words. Give you some time. All right, let's do this. It reads, again, a card is drawn from the deck and replaced. So first, before we get started, I want you to box the word replaced. Replaced. Now, in terms of probability, that does not mean that they take something different and bring it in. It means to put back in whatever they're talking about. To put back in. In this case, to put back into the deck. All right. So with that said, let's go through this process. Start with a formula. Here we go. P of A and B is equal to P of A times P of B. All right. So now you should be able to fill out the second portion. Fill it out. All right, tell your neighbor what you wrote for the second portion right there, substitution. What you write. All right, good conversations. Aaron, pass someone. Q and A. Hands, have you got that? That is correct. Q for queen, A for ace. So the probability of getting a queen and an ace is something times something. So think about it. Start with a queen. What is the probability of getting a queen from the deck? Tell your neighbor, please. What is the probability of getting a queen from the deck? All right, good. Sound T. Pass someone. Aaron. That is correct. 4 out of 52. Now think about it. They said that the card was replaced. What does that mean? Put back, right? All right. So therefore, tell your neighbor the probability of getting an ace. Probability of getting an ace. All right. Pass someone, Aaron. Santi. 4 out of 52. That is correct. Because each are independent, it doesn't affect the other. So that's why it's like starting from scratch. So therefore, calculators calculate 4 times 4 is 16, and 52 times 52 Did you get Vianney? What? Oh, you reduced it. Yeah, 1 over 169. But before that? 2,704. All right, so this is the answer, and this one is reduced. From 1 to 5, how comfortable are you with this so far? All right, send me your notes, please. All right, let's go to example 1 mega cube. Don't copy this one because it's a lot. Let me read it first, and it reads, a bowl, not in bowl, a bowl contains 2 red balls, 3 blue balls, and 5 white balls. A ball is selected and its color noted. Then it's replaced. Remind your neighbor what replaced means. All right, good conversation. A second ball is selected and then its color noted. So, on your paper, I want you to write example 1 mega cube, and I want you to write this down. A, selecting 2 red balls. Write that down, please. Selecting 2 red balls. So, 2 red balls. We have 3 blue balls and 5 white. Okay. So, let's start with the formula. P of A and B is the same as P of A times P of B. So, let me write it right above in blanks and tell your neighbor what you're going to write for each of those parts. Think about it. Think it through. All right. Diani, pass someone. Who? Oh, Corinne. So, what do I write instead of A? Red. And instead of B? Another red. That is correct. So, this is going to be P of R times P of R. So, P of R and R is what times what? Tell your neighbor what you're going to multiply there. We're going to pass someone. Aleshka. So, probability of getting a red one. You'll pass it to who? Alexa. Probability of getting a red one. 2 divided by what? That is correct. 2 out of the total, which is 10. How about the second time? Same thing, because it's replaced and put back in. So therefore, the probability of of getting a red and then the red is 4 out of 100. And if you simplify that, it's 1 out of 25. All right, from 1 to 5, how comfortable are you with this? All right, so find me B and C. Let's see how you do with that. Go. All right. Let's go for B. What'd you get for B? What was your total, Mel? before you simplify? 15 over 100. And then simplify, that becomes 3 over 20. Hands, have you got that? That is correct. Let's go. Now let's go to C. Let's see what you got. And Mel's going to pass it to someone. Santi, what'd you get? 6 over 100, or 3 out of 50. Hands, have you got that? All right, so we're good with independence. Send that in, please, which takes us to dependent. Copy this formula, please. Can you send that in? Multiplication rule number 2. And it reads, when two events are dependent, keyword here is what? Dependent. That means one event depends on the other, kind of like the story I gave you about my then friend, now wife. Let's go. One depended on the other. And it reads, P of A and B is equal to P of A times P of B. Now look up. This bar right here does not mean divide. This bar means dependent. Dependent. That's what this bar means. So, let me read it. P of A and B is equal to P of A times P of B dependent on A. Now, you might be asking yourself, what does that mean, Mr. Q? That means that when you find many times the first probability, the second number is going to be affected by the probability of the first. Okay? So, with that said, let's go to an example. All right? Here we go. And it reads, hold on, don't copy this. Let me read it out first. And it reads, 3 cards are drawn from an ordinary deck and what? Not replaced. Tell your neighbor what that means. Did you tell your neighbor already? Because this is what it's going to depend on this formula for that. All right. Then it says, find the probability of these events. Let's start with 3 jacks. So let's start. I want you to write A, get 3 jacks. Get 3 jacks. And we start with a formula. P of A and B equals to P of A times, my brain goes faster than me sometimes, P of B dependent on A. All right, let me make some space here. All right, so here we go. P of, what are they asking us for, guys? Jacks. So I'm going to write P of J and J and J. You're like, it's 3 things now, Mr. Hugh. Yes, it's okay. So that means P of J times P of J dependent on the previous J times P of the new J dependent on the previous J. So P of J and J and J. So think this through really quick. Don't say it out loud. Keep it to yourself. Here we go. What would be the probability, first of all, of drawing a jack? Tell your neighbor, probability of drawing a jack. All right, probability of drawing a jack, Max, what'd you get? Sorry? Pass it to who? Quinn. 4 out of 52. That is correct. Because there's 4 jacks right there. 1, 2, 3, 4. Okay. However, what was the key word in this problem, guys? It said not replaced. So they took out that card. All right? So, guys, turn to your neighbor. Let them know what is the probability of selecting a second jack. Tell your neighbor, please. All right, Query, pass someone. Who? Three out of 51. That is correct. Let's go. Why is that? Because now this number depended on the fact that we took the first jack out. Is that correct? Therefore, tell your neighbor the probability of the third jack. Probability of the third jack. All right, pass someone, Z. Vanya. 2 out of 50. Oh. 2 out of 50. That is correct. Therefore, calculators calculate. 4 times 3 times 2, that is 12, that's 24. What is 50 times 51 times 52 times 51 times 50? All right, who's got it? It looks like Carter's got it. Very good, Carter. 51 times 52 times 50, or 52 times 51 times 50, which is what'd you get, Carter? 132,600. And that is when we have dependent events. From 1 to 5, how comfortable are you with this? Yeah, 5 4s, 5 4s, all right. Send me your work. Let me send you the screen. All right. So, for the sake of time, we're going to stop right there, but I'm going to post the home play on the screen so you can get started. You're working on evens only, evens only. There's 1 through 7 there. I'm going to send you the last 3 onto your screen as soon as people send me their work. Those of you following on YouTube, make sure you get some practice in. See you guys next time. Peace.